looking at this one, let's try letting u equaling the denominator. It's always worth a try. If it doesn't work, we try something else. It's going to happen often that you just try something, it might not work. So derivative of e to the stuff is e to the stuff times the derivative of stuff, so there it is. So if I take this and just rewrite it as 1 over that times e to the 3 dt, I'm hoping you see it. This is this, right? So if I took and said 1/3 du is equal to e to the 3t dt. So I take out 1/3 du and I take out e to the 3 dt and I put in 1/3 du. All right, let's go back to what u is equal to. U is equal to this, so I get 1 over u. Oh, what is that? So that's 1/3 times the integral of 1 over u. Oh my goodness, you know it. It's ln of u plus a c, and you put the u back in. ln of 1 minus e to the 3t plus c. All right, let's go to the next one here. So let's see. Let's just try letting u equal the denominator. Many times that does something, so let's try it. So if I let u equal 4 plus x to the 4th, du is 4x cubed dx. Oh, do I have an x cubed up here? I don't. And it's not okay to just like divide through by an x squared or like that to get an x dx. You can't do that. You cannot have x's and u's together aboard. Something different needs to happen. All right, so you're going to have to be maybe clever because there's no other inside other than the denominator. Oh, I know. What if we rewrite that x to the 4th as x squared squared? Ooh, okay. So if I write this as x over 4 plus x squared squared. Okay, so then let's let u equal just that x squared. Du is 2x dx. Okay, take the time to separate it. 4 plus x squared squared x dx. I'm thinking x dx here can be taken out and I could put in a 1/2 du. All right, so what else happens over here? So then if I put in the u is x squared, I'd get 1 over 4 plus u squared. So I'm going to take the time to pull the 1/2 on the outside. Du. Okay, looking at this. Oh, right, there's that other thing on your memory sheet that's new. If it's a squared plus x squared, so not just 1 squared plus x squared, it turns out to be 1 over a inverse tangent of x over a. Whoa, okay, wait a second. The inverse sign, when there was an a, there was no 1 over a in the front, right? So that just turns into just x over 3, no 1 over a in the front. Just to be different, arctangent does have a 1 over a in the front. So I would get 1/2, that carries down, and then a is 2, so I'd get another 1/2 arctangent of u over 2, so I'd get 1/4 arctangent of x squared over 2 plus c. All right, so then let's look at number 9. So there's another thing I need you to know, and I'll just tell you up front that you need to know that there's an identity, and I'll always tell you what identities you need to know. There's not that many. So the identity of sine of 2x is equal to 2 times sine of x cosine of x. We are going to use this a lot, so make sure you memorize it. So let's think about this. What happens if I don't know, let u equal cosine? Then du is negative sine of x dx. That's not what's up there, is it? Nope, that's not going to work. Okay, So let's try u equaling the denominator. So if I let u equal 1 plus cosine squared x, I think I'm going to need chain rule, right? So if I take the derivative, du is 2 cosine of x times the derivative of cosine of x, which is negative sine x. Wow, that looks ugly. Wait a second. Do you see something? I think so. So my du is the same thing as saying a negative, right? I'll maybe just go one more step. Negative 2 times cosine of x, sine of x, dx. So this can be replaced, this can be replaced with that, right? So I get a negative negative sine of 2x. Well, that's kind of nice because that's what I've got in the numerator, right? So here, let me just separate it. 1 over 1 plus cosine squared x times sine of 2x dx. So let me move up so that I have room so you can see what I'm doing. Oops. Okay, so then here's the 2x. Okay, so look at that. I think I can take out sine of 2x dx and replace it with a negative du. And then this is the denominator, so I get 1 over u. Well, that's just negative ln of u plus a c. And then I put the x's back in, right? So I'm going to bring it all the way over here. So put the x's back in. So I get ln of quantity 1 plus cosine squared of x plus c. So that's the answer for number 9. Wow.